My name is Josie, and I'm a professional registered electrical engineer based in Australia, Melbourne. I basically work on building services in Melbourne, Sydney, and Brisbane. So, one of the main thing that I've come across in terms of Australian standard compliance is car park lighting or public area lighting. Main issues regarding this lighting most of the people face, or most of the people doesn't even look at it, is compliance with the AS 1158 and compliance with the AS 4282. The issue is basically looking at a car park and the client says, like for like replacement, which means where there is a car park lighting in the past, they'll just replace the lights from the older type to the new type. When you do that, you're not really complying with Australian standards is as such. In order for you to check whether this complies with Australian standards or not, you have to have a registered electrical engineer or a registered lighting designer in the project who can actually do the check against the Australian standards. The unregistered ones, what they often do is they just check the horizontal levels on the floor and then just say, this is compliant. But it includes a lot more than a horizontal check. It includes a vertical check. It includes a boundary level check, making sure everything is all right for the public in the car park and certifying it as compliant lighting design and electrical design. Let's go into the details of this design for now. This is a public car park somewhere in Brisbane. I don't want to explain the actual location, but let's go into the detail. I mounted the lights at 6 meter height, and the fitting had 67 watts approximately, and we had 17 fittings on the north and south of the car park. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. And what we have done is we have created the calculation point in accordance with AS1158. How we did that is we first checked the horizontal levels in the car park, do the average across the car park on the horizontal level. There is the uniformity, which is in for an external car park, it is always max to average, which this is where most of the people gets it wrong, because internally it is minimum to average, but in external circumstances it is max to average as per Australian standards. Then we check the vertical levels of the car park, which is this PC2 EPV1 and PC2 EPV2, which are two directions where people or the car travels in. There's a strict requirement for the horizontal and vertical calculation points, how they placed in the software, etc. The software that I have used at the moment is AGI32, which is really professional in Australia. Some people use Dialects, but AGI32 is what I like anyway. And then we also have in this car park, we have a footpath on the south side and a pedestrian crossing to the north side to get to the footpath on the path on the north of the existing car park. So what we had to do is the same status, like we have to, according to AS1158, check the horizontal levels on the footpath, which is this footpath south PP2 EPH, and we have to check the verticals on two directions where people travels on the pathways as well. And so we checked against it, and the naming PC2 and PP2 corresponds to the levels in the standard, which is a PC2, and pathway is a PP2 that we were aiming for. And I'll come down to the next point of obtrusive lighting. So I talked about AS1158. Sorry, just missed the pedestrian crossing in this. So pedestrian crossing also has a specific requirement in Australian standards, and this AS1158 recently updated the standard, and the requirements are really have changed a lot, and you need to really know what you're doing to say the pedestrian crossing is compliant with the new Australian standards. Now I have certified as PP2 this pathway as a PP2. Average was on 10.56, and the point horizontal was 1.4. Point vertical was zero point 0.4, and the uniformity was 2.76 on the footpath. So that was complying with Australian standard 1158 3.1. Now on the car park side, we were aiming for PC2. We have got three categories: PC1, PC2, and PC3, and we got a pedestrian crossing inside the car park, so which we need to separately calculate and make sure it is compliant with the standards. And the car park had a minimum and the uniformity in accordance with the PC2 levels, and then I certified this as a PC2 compliant car park. And also I've provided some renders. Now we will go to Australian Standard 4282, which is obtrusive lighting compliance check. As per the location of the project, we can categorize this as medium district brightness, and during the curfew, um, we were allowed to have a maximum allowable value of 2 lakhs at the boundary, or as per the new standard, it's not the boundary, the dwelling's face. In this case, we don't have any residential houses, so we really didn't have to check this, but we make sure from the project's property there's not really much light going outside. We didn't have to check this because there's no residential buildings around it, but we checked anyway to see what's the light level. It was under the brightness level allowed as per Australian standard. And then we also checked for the luminous intensity at the vertical planes to check what's the level at the property boundary. And also we've checked the upward lighting ratio in accordance with 4282. There was no roads next to it, so we didn't have to check the threshold increment in this case. And we were compliant with the lighting that we have provided in here, and we certified this as an RPEQ designer. I certified this design as a lighting design, and also we have provided lighting circuits back to the distribution board, some located somewhere over here in the building. And we provided new cables, 3 new cables to this, and we used the existing distribution boards. And we also assess the existing area for lighting level compliance, which is something that we always do. And we can upgrade them if it is necessary to be upgraded for compliance, or produce a report based on what's the light level on that area. So this is the car park lighting. So like I said, the main issue that I'm seeing is people saying like for like replacement and just swap the light fitting with a new light fitting without even checking the light levels or checking the standards, because nobody wants to spend money on compliance and public safety, etc. Why the compliance matters is, it's more of the safety and liability exposure. And most of the time, the building approval and occupancy issue for the new building and new developments need this lighting compliance as part of the approval process. And the other thing is neighbor compliance and obtrusive light dispute. Residential properties are common. Car parks where the border is a residential property is a common source of light spill complaint. It can escalate into formal disputes if not addressed at design stage. And ongoing running cost is basically another issue that actually makes the compliance is a factor. And yeah, so if you look at the car park, you would probably don't know if it is actually compliant with the standards or not. You need a professional registered electrical engineer or a professional registered lighting designer who can check the light levels. I am a professional chartered registered electrical engineer. If you have any car parks in Australia that actually needed to be checked and assessed against the compliance and produce a report, you can contact me. I've given my contact details in my in the description of the video, and also I have given a checklist inside the blog, inside my website. You can go and download for a free checklist that you can see and compare against your car park, so you know whether the car park is compliant or not. Project that you actually need a review or report, or even a peer review, then give me a call or send me a message from my website, or even I've given the contact in the description of this video. So I'll see you in the next video.